Hi guys, and welcome back to Chemistry 1032 Lab Example Problem Discussions. I am your host, Dr. Russell Betts, and I'll be guiding you through today's example. Today we are looking at example 10.1, Drawing Skeletal Formulas. Now, if we take a look at this example, we see that we have some condensed structural formulas drawn out. So we need to take these condensed structural formulas and we need to convert them into skeletal formulas. The skeletal formulas are essentially the line drawings that are much easier to look at once you get the hang of looking at them. But you have to understand what they mean in order to get the hang of it. So let's take this example here, the first example, and let's just quickly redraw it here just so we have something to work with. All right, this is a condensed structural formula more or less. It has a little bit of detail, but not a lot. And we want to convert it to the skeletal formula. Now, the skeletal formula has the least amount of detail, but it takes a lot of extraneous information. Now, that information is important. You need to know it's there, but you don't need to see it. So we need to basically take this drawing and make it look a whole lot neater and a whole lot easier to read once you get the hang of it. Now, in a skeletal formula, carbons and hydrogens are never shown. So as you can see in this drawing, lots of carbons and hydrogens are shown, but in a line drawing or a skeletal formula, they're never shown. So let me draw the answer. The answer would be, let me do that a little better. There we go. There we go. That is the answer. This is the skeletal formula of that. Now, let's explain how we get there. And I think by showing you the answer, then explaining how I got there will be much simpler. Now, the first rule for skeletal formulas is that wherever a line terminates, such as here and here, that must be a carbon. So this is a carbon, and this is a carbon, because the line stopped there. Now, the other rule you have to know is wherever two or more lines intersect or come together, that's also a carbon. So I'm looking, if you will, I'm looking here and here. Those are also going to be carbon because that's where more than two lines, two or more lines intersect. So let's fill these carbons in. Carbon here and carbon there. I use different colors to help differentiate between them, but they are the same carbon. Now, we know, because we've studied chemistry, that carbon must have 4 bonds. So far, these carbons in my drawings have either 1 or 2 bonds, but they need to have 4. For example, this carbon right here has 1 bond. It needs to have 4. Those other bonds must be to hydrogen. So let's draw them in. So there's a CH3 on the terminal carbons. So both red carbons have 3 hydrogens on them to make up the octet. Remember, it's the octet rule that rules over all of this. Every carbon must have an octet. If a carbon only has 1 bond, it has to have 3 more somewhere. It can never exist with less than 4. So now we have this carbon here. That carbon has 2 hydrogens because it already had 2 bonds, one to a carbon on the left, one to a carbon on the right. So the other 2 bonds must have been hydrogen. So the green carbons have to have 2 hydrogens each. Now, we've taken our skeletal formula and we've converted it back to an expanded structural formula. So let's just, rewrite it again as the skeletal. This is the skeletal formula. Okay, so that's how you do it. That's the first one. Every carbon must have 4 bonds. In a skeletal formula, the carbons and the hydrogens are never shown. Other atoms must be shown, though. If no atoms are shown, it's assumed to be a hydrogen. So in your skeletal formula, if you have non-hydrogen or carbon atoms, you must draw them in. So let's take a look at this one now. Let's take a look at that one. Well, we've got a whole bunch of carbons, a whole bunch of hydrogens, and we have an oxygen right there. So we're going to have to draw that in. But remember, in a skeletal formula, carbons and hydrogens are never shown. So this carbon, that carbon, and that carbon, we're going to have to get to not get rid of, but just not draw them in so we can see them. So this drawing here will look like this as a skeletal formula. Let me draw that a little bit nicer. There we go. Those should touch, and the oxygen goes up there. Now this drawing right here is the skeletal formula. Let's take a look at this formula a little more closely so we can kind of examine the structural details. Now again, remember in the skeletal formula, wherever lines terminate, that's a carbon. Okay? Wherever lines terminate, that's a carbon. Wherever two or more lines come together, that's also a carbon. So there you go. The green carbons designate the carbons. The carbons where two or more lines have come together, or two or more bonds have come together. Now, remember, every carbon must have 4 bonds. So let's take a look at this carbon right there. That's not an electron, that's just a dot to designate the carbon I'm looking at. That carbon has a bond to the left, a bond to the right, and 2 bonds going up. So that carbon already has an octet. It already has 4 bonds. So we're not going to do anything with it. We're not going to give it any hydrogens. We're not going to do, oops, that was big. We're not going to do anything to it. It already has 4 bonds. So that must be correct. Now let's look at the red hydrogens on the ends. They each have 1 bond. So they must have 4. So let's just draw them in. 1, 2, 3, and the bond it already had is 4. Let's do the other red hydrogen. It already has a bond here, 2, 3, 4. And now we're going to look at the green carbon in the middle. It already has a bond here. It already has a bond there. So it has to have 2 more bonds. Now I've taken the nice skeletal drawing we made and I've turned it back into an expanded drawing, but that's okay. Let's just do it one more time. We'll show the expanded structural formula and we'll turn it into the skeletal formula. Now, trying to make those bonds look pretty. There we go. So this is also a skeletal formula. Notice the oxygen is shown, but the carbons and the hydrogens are not. Okay? That's very important. Let me just draw a line here to separate my last one out. So now we're going to take a look at this one. This is an ester, so it has a non-carbon hydrogen atom here and a non-carbon hydrogen atom there. Not a big deal. Not a big deal. Just remember you have to show it. So let me draw the answer and then we'll break it down. So there's my double bond to oxygen, my carbonyl. There's my bond to the other oxygen, and there's my bond to carbon. That is the skeletal formula. So let's do what we did before. Let's just break it down. Where lines terminate, that's a carbon. So there's a carbon there and a carbon here. And where 2 or more lines come together, there's a carbon. So there's also a green carbon there under the carbonyl. Remember, carbon must have 4 bonds. This red carbon right here already has a bond, so it must have 3 more, and those must be to hydrogen because nothing else is shown. This also must be to hydrogen, 3 bonds. There you go. But now let's take a look at that green carbon, this one right here. It already has 4 bonds, so we're not going to give it any more. It already has an octet. It's already completely happy. So don't bother putting any more bonds on it. If you do, it will be wrong. So let's just redraw the skeletal formula one more time. And there you have it. This is a skeletal formula of that. Okay? So now, please take a look at this example in your book. Do it yourself. Make sure you can convert a condensed structural formula to a skeletal formula. In the lab, we're going to be working back and forth through all of these types of structural formulas to make sure we understand it, because all of these kind of structures are used a lot. Skeletal formulas are used quite a bit, but so are condensed formulas. So we have to be able to move in between them relatively simply. And once you start practicing it, you will get the hang of it, and you'll notice it's really not all that hard. So with that, I would ask you to please do your work. Make sure you do your pre-labs and all that. But also, if you have any questions, please come to my office hours or please go see one of the tutors in the Academic Success Center. They are certainly there to help you. All right? Now with that, I wish you good luck and good chemistry.